You can make someone else burst out laughing just by touching their ribs. But when you try it on yourself, nothing. No laughter. No squirming. Not even a flinch. Why does your own touch feel completely different from someone else's? The answer lives deep inside your brain, in a region called the cerebellum. And it reveals something remarkable about how your brain predicts the future. Let's start with what tickling actually is. There are two kinds of tickle. The first is nysmesis, a light, crawling sensation, like a feather on your arm. The second is gargalesis, the deep, uncontrollable laughter-inducing kind. That second type is the one you cannot do to yourself. And the reason comes down to one word: prediction. Your brain is not a passive receiver of information. It is a prediction machine, constantly guessing what will happen next. Every time you decide to move your hand, your brain sends two signals. The first signal goes to your muscles, telling them to move. The second signal goes to your sensory cortex, a warning: touch is coming. This second signal is called an efference copy. Think of it as a carbon copy of your movement command, sent to your senses. The efference copy tells your brain exactly what touch to expect. When the actual touch arrives, your brain compares it to the prediction. If they match, the touch is cancelled out. Your brain literally subtracts the expected sensation from the real one. The result? You feel almost nothing. But when someone else touches you, there is no efference copy. Your brain had no warning. No prediction was made. The touch arrives as a complete surprise. And surprise is exactly what makes tickling unbearable. Your brain cannot cancel what it did not predict. So the sensation hits full force, and you lose control. This is why being tickled feels so different from touching yourself. It is not about the touch itself, it is about who controls it. The cerebellum is the part of your brain that runs this prediction system. It sits at the back of your skull, about the size of a fist. It processes movement, timing, and coordination. And it is constantly modeling what your body is about to do. Scientists at University College London tested this directly. They built a tickle machine, a robot that could touch people's palms. When participants controlled the robot themselves, they felt almost nothing. When the robot moved on its own, participants reported strong tickling sensations. Same touch, same location, same pressure. The only difference was whether the brain predicted it. Then the researchers added a twist. They introduced a time delay between the participants' movement and the robot's touch. Even a delay of just 200 milliseconds was enough. With that tiny gap, the prediction no longer matched the sensation. And suddenly, the self-generated touch felt ticklish again. The brain's prediction had expired before the touch arrived. This tells us something profound. The brain does not just process what happens, it processes what it expected to happen. Sensation is not raw data. It is data filtered through prediction. Now here is where it gets even stranger. Tickling is not just about sensation. It is also about social bonding. Laughter from tickling is one of the oldest forms of play. It appears in primates, rats, and even some birds. Rats, when tickled by researchers, emit ultrasonic chirps, the rat equivalent of laughter. They actively seek out the tickling hand. This suggests tickling evolved as a social signal, a way to play safely. And that is why it requires another person. You cannot play with yourself the same way you play with someone else. The unpredictability is the point. Now think about what this means for your sense of self. Your brain is constantly distinguishing between self and other. Between what you cause and what happens to you. This boundary, between self-generated and externally generated, is fundamental. It is how you know your own thoughts are yours. It is how you know your own voice sounds different inside your head. It is how you avoid being startled by your own footsteps. The efference copy system runs silently in the background of everything you do. Every time you speak, your auditory cortex is pre-dampened. That is why recordings of your own voice sound so strange. You are hearing it without the dampening. Every time you move your eyes, your visual cortex is pre-stabilized. That is why the world does not blur every time you blink. The Tickle system is just one window into this vast prediction architecture. And when that architecture breaks down, things go wrong. In some forms of schizophrenia, the efference copy system is disrupted. Patients sometimes cannot distinguish their own thoughts from external voices. The brain loses track of what it caused and what was done to it. Some researchers have even found that people with schizophrenia can tickle themselves. Because the prediction signal is weakened, the cancellation fails. Their own touch arrives as a surprise. This is not just a curiosity, it is a diagnostic clue. The Tickle test has been proposed as a simple way to probe this system. So the next time you try to tickle yourself and feel nothing, that nothing is actually something remarkable. It is your cerebellum, running a perfect prediction in real time. It is your brain drawing a precise line between you and the world. Between what you control and what controls you. You cannot tickle yourself because your brain is too smart to be fooled by you. And that intelligence, that constant, silent prediction, is what makes you feel like a self at all. A single violin over a whisper. These moments break your prediction. And your skin answers instantly. It happens across every culture. Every language has music that moves people. It may be part of being human. A gift wired deep inside us. So don't take your chills for granted. They are a small daily miracle. So here's the wonder of it. A pattern of sound waves becomes a storm of emotion in your body. Ancient survival wiring, repurposed for art. Your goosebumps aren't about staying warm anymore. They're about being moved. Music found a back door into your feelings. And your whole body answers. So the next time a song gives you chills, don't shrug it off. It's millions of years of biology. Meeting a moment of pure beauty. And for a few seconds, you get to feel truly alive. Thanks for watching.